Combining, simplifying, kind of like we did with the distributive worksheet and those two assignments, and solving equations. We're kind of combining those two together. So we're just going to jump in here. There's nothing that's really new. It's more that we're just combining two things that we've already done. All right. So you need to write the equation and show work. Number one, so we have to simplify one side of the equation. The right side, they've left simple, so there's nothing we can do on the right. But the left side on all these, we can simplify. So, let's see, where should we start? Any volunteers? Volunteer for tribute? No? Okay. All right, Eleanor, how would that simplify right there? So that would become what? 12a equals 12. 4a plus 8a. If they are like terms, they can add together. 4a plus 8a become 12a. And then what would our step be to solve, Eleanor? Divide by 12. So that goes away. We get a equals 12 divided by 12 is 1. Okay. Negative 2c plus 2c. Let's go. Leah, do you know what we could do on this left side over here? Okay, we do want a minus 2 eventually, but before we do that, let's try and simplify this. Like, how can we make this simpler? Okay, we can put our like terms together. So, like, negative 2c can go with minus c. Actually, yeah, you probably missed some of this assignments last week. So, negative 2c minus 1c is negative 3c. And then the plus 2 we didn't really do anything with that, so it just stays there. And now you have a kind of an equation from yesterday, right? After you simplify it, it kind of looks like yesterday. It's just a basic equation. Any questions on that? You good? Okay, here's the thing. If you want to do that first step in your head, you could start by writing this down if you want to, instead of the original problem. That is an option. So you can do one thing in your head. All right, and then, Leah, what did we do after this? And then what? Okay, so we got C is negative 6. As always, if you wanted to check it, you could plug it back into the original problem. Make sure it works. Makes both sides equal. All right, 4w minus 7 equals 8. Rain, what should we do with this first? Right. So 4 times w is 4w. And 4 times negative 7, minus 28. Now it's normal looking. So what do I do? Okay. Good. -7, y plus 3 equals 7. Alright, let's see. Clara. No? Okay, what does it mean when 7's right next to parentheses like that? Yeah, it means multiply. So actually you could divide both sides by -7 since this is multiplied to the left side. But I think it'll probably be less confusing if we go ahead and use distributive property because we're used to that. Yeah, so we'll multiply it out. So -7 times y is -7y, and -7 times 3 is -21. Alright, Allison, we did a few of these back on the distributive property. Do you remember what happens when there's a minus right in front of the parentheses? Well, it's kind of still distributing, but you have to subtract both of those. So, it's 5m minus 3. And it's also, this is where people usually get this part wrong, it's also minus 2m. Kind of like that. So, why didn't we multiply the 5 on this? Well, 5's not next to the parentheses, but the minus is, so you gotta subtract both of these. Minus 3, minus 2m. And then, Allison, how could we simplify this left side? Any ideas? Well, we are going to do that eventually, but let's try and make this left side look a little simpler. What can we do to clean it up? Well, we can add together our like terms. So like, what can this 5m go with? What can this 5m go with? Yeah, minus 2m. So 5m minus 2m. Starting to get warm in here, isn't it? Heating up. Alright, it'll probably turn on a little bit. And then this minus 3, we didn't really do anything with that, so it just stays there. That makes sense? Okay, now it's like yesterday, so what do we do at this point?
Add 3.
So we get 3m equals 12, and then what? So m is 4. I don't know why that circle messed up. I think my sleeve keeps hitting the board and like messing with it. Okay, 6 minus 2, 2 plus 4 equals 108. All right, Draven, what do you think we should do first? You're very close. Change something slightly. Do you know what it is? Yeah, I would think of that as a -2. Yeah, those kind of go together. So So 6 stays there. Negative 2 times p, negative 2p, and then negative 2 times 4 is negative 8. So we're just going to put minus 8 there. Okay, now the left side's a little messy, so how can we clean it up? What are the two like terms? Right, 6 minus 8, those two can go together. So 6 minus 8 is negative 2, and then this thing, we didn't really touch it, so that's still there. Okay, the order's a little bit different than normal, but now what, David? Add 2. And last step. Alright, and p divided by negative 2 is like negative 55. Or, sorry, 110 divided by negative 2. Negative 55. Two minus plus 3 minus 5 equals 34. So I'll repeat myself. If you do want to do the first step if you feel comfortable doing the first step in your head, that's fine. Just show your work after that. Let's see, what number is this? 13? Yeah. All right, Luke, what should we do first on this one?
Times 2 by 9s and by 3.
Right. So 2 times 9s, 18s, 2 times 3. That's still there. That's still there.
And then combine 18s and 4s.
18s minus 4s. Okay, and now, a couple steps later, it looks like yesterday's. So back to the basics here. Minus 6. I might not ask you about the basics as much anymore when I start feeling you guys are pretty good at that part. Alright, same stuff. I guess it's got a decimal this time, so it looks a little different. Hallie, what should we do on this one?
Distribute with the 4.
Yes, multiply comes first. Okay, so we got 3.2k plus 4 times k plus 4 times 7 is 28, so if there's a decimal place, it becomes 2.8. Okay, now what?
Add 3.2.
Right, add the k's together. That simplifies. 3.2 plus 4 is 7.2k. And now we got it down to a basic.
So minus 2.8.
Oops. noticed this in the other class, none of the odds or evens today come out as fractions, which means they're also not decimals. So if you get a fraction or a decimal, you did something wrong. So you can kind of check yourself. If you screw up, it's likely you'll get a fraction or decimal. So if you get it right, if you don't get a fraction or decimal, it's pretty good odds that you got it right. Not guaranteed. Okay. All right, so a couple word problems today. Might be introducing a couple new concepts here, so you guys might want to pay attention to this. We're doing a little bit of this in chapter 1. Chapter 7, we're doing a lot of this. So this is kind of a preview for something we'll do later. Let's see, Katie, one number is, okay, so Katie, what do you think we should put for one number?
F.
Right? And do you remember what is meant?
Equals.
Hey, you stole your answer. Hey, you stole her glory. Okay, one number is, so one number equals, n equals 23 more than. What do you think 23 more than means?
Plus.
Yep, you're right. Because if I said, you know, he's 5 more than your age, that's like your age plus 5. So 23 more than would be 23 plus. Then it says another number. What should we put for another number? Yeah. If it's a different number, then you don't want to put n again, because if you put n twice, that would be the same number. So you want to use a different letter. N and M kind of go together. But you could use X, doesn't really matter. My personal preference is A's and B's. Okay, now is this solvable right here? Hey, stop doing the evens and pay attention, guys. This is the hard part. There probably will be a word problem on the test or two, so you need to know how to do this. Okay, is this solvable right now? No. Because if m is like 1, this would be like 24. If m was 2, this would be like 25. So cannot solve this. So we need more information. It says the sum of the two numbers is 83. So Katie, do you remember what sum meant?
The equal.
No, not equal. Okay, help her out. What did sum mean? Adding. So if it says the sum of the two numbers, what are the two numbers?
83 and 22.
No, the two numbers are what we called m, and then we said the other number was m. So the sum of those two just means if you add those two numbers together, it should equal, what was it, 83? The sum is 83. Okay, here comes the trick. Are you guys watching? Pay attention. So this isn't solvable. Is this one solvable? No. When you have two variables, like maybe this is 80, maybe this is 3, that would work. Maybe this is 70 and 13. Cannot solve a two variable equation. So here's where the trick comes in. If n is equal to 23 plus m, that means I can change this n in the other equation into 23 plus m. Do you guys follow that? If these two are equal, that means this can be replaced by that. That's kind of what equals means. They got the same value. So this n on the second equation, I'm going to replace with 23 plus m. So basically, I rewrote the second equation, but with where the n was, it's called substitution. I replaced the n with what n is equal to. Now, how does that help me?
It makes it solvable.
You got a one variable equation, which is solvable. M plus m is 2m. Okay, like I said, we're not doing much of this in chapter 2, but chapter 7 we're doing a lot. the big. Chapter 7, we're doing like 3 things, and this is one of them.
When is it possible for us to even get to chapter 7?
January. That'll be January.
Okay, so we have a few weeks to go before
A
that.
few months, yeah. Okay, so now you can see it's normal though. So we're gonna do the normal stuff after that. You could kind of play around with numbers in your head until you found something that worked for these 2 conditions.
Then I'll take 5 off.
That might take a while. This is the algebra way of doing it. Okay. If you divide by 2, we get n is 30. Well, normally that's where we stop. However, remember there were 2 numbers, m and n. So how would I find the second number?
N plus 3 equals 83.
Okay, yes.
30.
We could use either of these equations. N plus 30 equals 83, and you could solve that for n. Or, this one looks a little easier, 23 plus 30 would give us n. So 23 plus 30 is 53. Okay. Unfortunately, I noticed this at the end of the 22 is similar to 21. However, it's different enough. Maybe I'll just do the first part with you guys. It's different enough that even if you got how I did 21, you probably wouldn't get 22. Okay, so everybody help me on this one. It says 2 numbers whose difference is 12. What does difference mean? Subtraction. And like I said, I like A's and B's, so I'm going to do A minus B, is 12. Their difference is 12. Ooh. And then it says, and their sum is 40. So what did sum mean? Addition. Does anybody see the problem here? Why is this not working like the last one right now? Well, the last one we had an equation that said n equals blah, blah, blah. And then we could just replace n with that. This one does not say a equals or b equals. So we have nothing to replace a or b with. However, we can make it say a equals or b equals. How do I get a by itself on this equation? How do I get rid of this guy? Add b. We haven't done that yet this year. This is the first time we're moving a variable around. I think tomorrow we're going to do it a lot, if I remember tomorrow's. Anyway, same way you would add a number. So over here, those go away. What's 12 plus b? The correct answer is, I don't know, b plus 12, 12 plus b. And the order of addition doesn't matter, so you could say 12 plus b or b plus 12. All right, one more part. What did I do on the last problem when we had, if we have a equals b plus 12, what can I do with this b plus 12? Right. Go to this other equation, and we can exchange this a for that, because these two are equal. So if a is b plus 12, and I can rewrite this equation. Okay, that's where I'm going to stop. Remember, there are 2 answers. So if you only get B, that's only half credit. You have to get B and A. Bug me. Okay. 23. Alright, it says the sum of three consecutive integers is 84. What does consecutive mean? Consecutive. This is not necessarily a math word, it's just a word. You guys know what consecutive means? It means in a row. Like consecutive days would be Monday, Tuesday, Wednesday. Like Monday, Wednesday, Friday would not be consecutive days. So what are consecutive integers? You guys remember what integers are?
Negatives.
Well, and positives. -3, -2, -1, 0, 1, 2. It's just no fractions or decimals, basically. So if I don't know what the consecutive integers are, how do I write them with variables? Well, if I call the first one n, what could I call the next one? Okay, we could call it m. Here's the problem. If we have more than one variable, that's a problem. But if we're talking about consecutive variable or consecutive integers, what do we know? Like, let's say they're like 7, 8, 9. So what do we know is always going to be true about the next integer? It's one bigger. Okay, so if we call the first integer n, the next one we could call n plus 1. Because let's say we knew that n was 7, then this one would be 7 plus 1, which is 8. And the next one after that would be 7 plus 2, which is 9. So this is how you write consecutive integers. And they ask for 3 of them. It could keep going, but they only ask for 3. Okay, it said the sum of 3 consecutive integers. What does sum mean? Addition. So if we add these together, now do I really need parentheses here? No, it's just kind of showing the 3 separate numbers. The sum of 3 consecutive integers is 84. All right. Now, how can I simplify this? Does parentheses matter when we're adding? No, it doesn't. Okay, so what's n plus n plus n? 3n. 1n plus 1n plus 1n. So it's 3n plus 1 plus 2, so that makes plus 3. Okay, so we just clean it up a little bit. Alright, now it looks normal again. So we're doing normal stuff. Okay, is n equals 27 the answer? Kind of, but it's only one of the answers. So if n is 27, what's the next consecutive integer?
28.
Right, 27 plus 1, 28. 7 plus 2, 29. They're just consecutive integers. And you could check this because these 3 are supposed to add up to 84, based on what the problem said. Do they add up to 84? Well, yes they do. Okay. 24, I'll help you guys set this one up too, kind of like the last one. It has another little shift on it. It says find 3 consecutive odd integers. So not just consecutive integers. Let's start with this. What if it was consecutive even integers? If the first one is in, like what's an example of consecutive even integers? 2, 4, 6. Okay, so if I call the first one in, if it's even, what would the next one be called? How much do evens go up by?
Plus 2.
Right, they go up by 2s. The next one would be called n plus 4. The next one, n plus 6. So That's what consecutive evens look like. Now, what do consecutive odds look like? Okay, how much, this tricks people. How much do odds go up by? 2. They go up by 2 as well. From 1 to 3 to 5 to 7, those are jumping by 2. The difference is, like, the first number has to be odd, and then the second number, when you add 2, will be odd. And the third number, when you add 2, will be odd. So, both evens and odds look like this. So, the sum of 3 consecutive odd integers is 57. Okay, and then that's where I'm going to stop. Yep. Yep.